The next Pwn challenge was Pwn Redact. It was a medium challenge with 41 solves by Kaifate. Sorry if I'm mispronouncing that. It says, I heard C was insecure, so I wrote my own flag redactor program in C++. Note there are many optimized implementations of memmove. We're not going to use memmove. We're given the netcat port, a C++ file, thank you, a Docker file, and the challenge binary. If we look at the C++ file, again, a nice short program. It's going to ask for some text, going to do a get line, ask for a placeholder, ask for an index, and then it's going to do a bounds check, and then it's just going to write over the text with our placeholder at the index. I didn't actually see the bug at first. One of my teammates found it, but the bug is here. So it's going to check if index is less than 0 or if index is greater than these. And at first this seems fine, but then you have to remember that text.size and placeholder.size return the std standard size t, which is actually a uint, an unsigned integer. So when you do this minus, it'll wrap around because uint can't be negative. And so you can do a buffer overflow that way. And so basically you'll just have your placeholder overwrite the text. Once you know that, this challenge really wasn't too bad. So we have a buffer overflow, and at this point we can just start ropping. So let's clear this. So we can look at the protections. So we'll do a checksec file is equal to redact. We'll see that there's partial row, so we can overwrite the got, which could be useful. There's no canary, so we're definitely going to be doing a buffer overflow. There's no pi, so we can run the exploit multiple times without an info leak, assuming we can overwrite the RIP on the stack. And NX, so we're not writing shellcode. So like I said, not a terrible challenge. We have a buffer overflow, we can ROP, and then we can jump back to the start of main, so we can execute this multiple times. And that's what I ended up doing. So the first time this executes, I'm going to overwrite the stack. I'm going to do a ROP chain that calls these lib. So I think the hard part with this program is normally, like, if this is a C program, you'll have like reads and writes and puts and gets and printfs, and these functions are very easy to kind of manage. But this function's a little bit more difficult. Like if this is an operator, and calling it just isn't quite as simple, but it really isn't too bad. I'm going to load Ghidra in the background. Cool. So we're just using Pwn tools again. We're going to start up the binary, set some context, and we need to figure out some values. So like I said, we're going to do two different ROP chains. In the first ROP chain, we're going to leak libc, and in the second ROP chain, we're going to jump to system bin shell. To leak libc, we need a couple different things. We need something that contains an address to libc, and we need a way to print it. Again, since it's a C++ binary, it's a little bit more difficult, but basically if we can figure out how this works, and we find something that contains an address to libc, that should work. And so that's what I ended up doing. If we do redact, let's break main, start, look at the global offset table. So we need something that contains a value to libc. I ended up using this @exit function. The challenge description said something about memmove, so I wasn't going to trust it. So I'm going to use @exit, which is a function defined in libc. And so at this address of 404050, it contains a value to libc, this address. So if we were to print the contents of this memory address, we would get this. So we're going to save that 404050. Again, it's this stuff. So to figure what these are, I don't really look at all this stuff. I don't really bother trying to figure out what it means. So instead, I just look in Ghidra and see what it looks like to print something. And so this is the main function loaded in Ghidra. We can see here it's doing the cout, enter some text. And to call this, it's going to load some text, a string, into RSI. Then it's going to load the standard cout to RDI. And then it's going to call this function, and we can get the address of this function here. So we can copy this. We also need the addresses of the cout. Thankfully, this is at a known offset. And so this is here, 4040 C0. And we can see in the solve script, I have these. So this is our gadget for how we can print things. We just need to make sure that we set up RDI and RSI correctly. Cool. So again, recapping, we have a buffer overflow. We're going to start ROPing. In our first ROP payload, we want to print an address of libc. So we're going to start using the Pwn tools ROP gadgets. We're going to load a ROP object. We're going to set RDI and RSI to the thing we want to print. And here's the cout address. So this is like this thing when you do a the high, so I'm guessing it's this object. Then we're going to call the print statement, and then we're going to jump back to the top of main. So we already know where the offset is of where ROP starts, so we know where to put our ROP payload. And we do the same sort of thing. We send some garbage text. This is the placeholder that'll overwrite everything, and then I just do a redact at the start. From there, that'll return the address of libc. And so we can calculate the address of at exit, and then like looking at our leak value and where this is, and then doing a VM map, and looking at where libc is. Where's libc? Libc. We can figure out where the base is and do some quick subtraction to figure out the base of libc. Cool, so now we're at the top of main and we can start our next ROP payload. And this time we're going to use ROP. We're going to call system, and we're going to search somewhere in libc. There's this string is defined, so we're just going to search for that string within libc, and we're going to call system on it. So nice and simple. We're going to do the same sort of payload. For some reason, something was eating. Some new line was passed at some point, and so I don't actually need this anymore. I'm not really sure why, but I'm guessing I'm just sending some input at some point that has an extra new line character, so you can ignore this, and the payload still worked. But we'll send our second ROP payload, and this should just spawn a shell. So we can run it. We can just run it remotely. Everything should work. Cool. Let's do Python 3 solve. Oh, got an end of file. Doing something wrong. Oh, I think they changed ports, didn't they? 31281, 312. No, 312. Let's try that again. Got an end of file. Interesting. That libc looks good. Enter the index of the stuff to redact. Switch to interactive mode. Got an end of file while reading it. I wonder if this got fixed and we need it. Wonder if it's working remotely. Actually, I wonder if I'm on a Debian system. Make Debian. And I was using the wrong version of libc. No. Well, 2 seconds after I stopped recording, I figured it out. It was, so I was running on Ubuntu when I should have been on Debian, and I think it was using the wrong version of libc maybe? I'm not really sure. And I do need this commented, so there were 2 variables. Either I was running on Ubuntu or Debian, and I had this commented and I did all 3 of the wrong combinations before doing the right combination. So now we can just do Python solve. And bam, interactive mode, ls, we can cut out the flag. So, a reminder to self, always make sure you're running your Docker container, which is the same as the remote system. I was running it in an Ubuntu system instead of a Debian system. Maybe it was grabbing the wrong libc, I'm not too sure. But yeah, now it's working, and there's the flag, so fun challenge. See ya.